So, okay. So this is a quantitative analysis, and we will combine a lot of topics here. Like if you look at the topic 1, it is asking for functions. Topic 1 is asking for functions. And then the second topic is matrix algebras, matrix. And then topic 3 is asking for calculus. That is a differentiation and integration. So we will be applying. We can tackle this one at once because you will be given a function. Then you need to apply calculus for you to calculate that function. At that time, you need to apply a function to form a matrix, or you will be given a matrix. At the end of it, you are forming a function. So you need to, these three functions, matrix and calculus, they go one in hand. So once we do one question or two questions, we will cover the function, the matrix, and the calculus. So that now we'll be remaining with statistic, probabilities, hypothesis, correlation, and regression. We have time series, linear programming, and decision tree. So we'll be picking the one which we can finish very fast. Like maybe after that, we can go to decision tree so that we master that immediately. So now, so we can start with looking at functions. So we will not divine it because it is very rare in quantitative analysis. You have been asked to divine what is a function, but a function is something that it enable us to form an equation. This enable us to form an equation, and then it enable us to form an equation in form of maybe a linear equation, a linear equation. This linear equation, is the one which will help you to get it will help you to get the cost, the profit, and the revenue. Remember the profit and revenue, cost, profit, and revenue. These are the two different things. This one is after we have adjusted the cost, but this one is before adjustment of the cost. So this function now, which it can be a linear equation, will help you to get the cost, the profit, and revenue. So that's why now we have the function. So these functions, a minute, I put ink here. So this function now, we can look at the examples, like we have the cost function. So we have so we can have this function. We can have the cost function, the cost function, the cost function, which this cost function, we write it as TC. TC is the cost function, is the cost function. TC is the cost function. And how do you get the total cost? How do you get the total cost? The total cost is the average cost times quantity. The average cost times the quantity. And then we need to get the profit function. We need to get the profit function. You need to get the profit function. Profit function is simply you represent at I equals to the total revenue minus the total cost. The total revenue minus the total cost. So now we need now that revenue function. We need the revenue function. We need the revenue function, which in this case, the revenue function, we write it as TR equals to the selling price, or the price times quantity. The price times quantity. So these are the functions which you need to master. These are the functions which you need to master. Number one, to set the cost function, which is average cost times the quantity. Number two is the profit function, which we take the total revenue minus the total cost. And then the revenue function, which is profit times the quantity. Profit times the quantity. So once you have done with this, and then we will come to, I think we can look at the, so that we look at one question. I want we at least we form the part of this. Have you written this?
Yes.
So we can look at how matrix, we form the matrix, and then we go to the calculus, the overview, and then now we go to the illustration. We go to the illustrations. So let's look at the matrix or calculus. We can go to the calculus first. So calculus also is another one to which we get the function to the derivative function. So from this derivative function, we can get the minimum point, we can get the maximum point. So this calculus is the one which enable us to get the maximum and minimum, the minimum point, the maximum and minimum point of the function, the maximum, the minimum point of the function. And we have differentiation, and also we have the integration. We have integration. We have differentiation and we have integration. We have differentiation and we have integration. For example, you will be giving the examiner will be giving you this one, the maximum revenue, or the maximum revenue or the maximum cost. The maximum revenue or the maximum cost. And at the end of it, you will be required to calculate the total revenue or the total cost. So you will apply this concept, differentiation and integration. Differentiation and integration. Good. So assuming you have been given this equation, which it is just an equation which is x squared minus 2 minus 2x, x squared minus 2x. And then you are being told to do a differentiation. To do a differentiation, what do you do? So it will be, you will be multiplying this. So this one, you subtract by 1 and multiply the power with this. So if it is to differentiate this, it is to differentiate that, it will be 2x minus 2. 2x minus 2. So you take the power minus 1. You take the power minus 1. And then that power, you multiply with the common value here. So ukiangalia hapa, the power is 1. It is only that we have not been shown. There is a power of 1 here. So 1 times this, itakuwa 2. But minus 1. So that's why imekuwa 0. That's why imekuwa 0. And then, so you need to understand how to differentiate that. You need to understand how to differentiate that. And then, if you have been told to integrate, how do we integrate this function? How do we integrate this function? So first, we have to bring in a constant value. First, we have to bring in a constant value, which is c. So we will say x squared minus 2x plus the constant, which is c, plus the constant, which is c. Then now, the powers, this one, you add by 1, you add 1, this one, you add 1, and then that one, you also divide. You also divide. You add 1 and divide. So this one will be 3. It will be x cubed over 3 plus minus 2x squared, we divide by 2. So you have to cancel the common factor, plus c. So which at the end, we will have 3x cubed minus x squared plus c. That is the, if you to integrate this function, if you are to integrate this function. So you must get that concept of how to integrate and where to apply. So we will be applying at this point. You will be given the maximum revenue and the maximum cost, and then you have to go back to get the function you are looking at. That is the revenue function and the cost function. The revenue function and the cost function. So I think that is that's very clear, or kuna clarification you need? Yeah.
Yeah, maybe just someone can ask.
Yes.
Maybe the formula for integration. Where are you getting the constancy?
So there is no formula, but it is a rule. It is a rule which we add this c. So unajua we don't know hizo principles kwa imetokaje. So unapewa, if you to integrate, you be given n power, like yes, n power. So for example, in differentiation, so it'll be this one is just a number, but utapata kuna power, right? So in this form, if it is to integrate this, if it is to differentiate this, unapata you take the power plus 1, right? That power also you multiply with the number. This one we subtract for that is for differentiation, we subtract. And then now for integration, which is nx itakuwa plus 1, and then this one also we divide here, x plus 1. But and also the rule telling us we add the constant. We add the constant, which is c. We add the constant, which is c. So this is a derivative function. So how they arrive with that principles. So we don't know now the rule behind adding the constant, but if you apply that constant, automatically we'll be looking at. So I think when we do illustration is we'll be able to understand how this constant will help us to get that unit. Remember, this constant, when you talk of the linear equation, does the linear equation have the constant?
Yes.
Yes, that's why now we are bringing in a constant value here so that we can have a complete linear equation. We can have a complete linear equation. So, before imeshaanza kunyesha. See if there is a disturbance or we just continue. Now, after that, we have to go to look at the concept of matrix. Let's look at the concept of matrix, and then now from there we can look at the illustrations. So we have matrices. So matrix is just we are forming an equation through the matrix. So this matrix also we have what is called the addition matrix. We have subtraction. We have multiplication. We have what is called the scalar matrix. You also need to know what is a determinant. You also need to know the inverse of matrix. So these are the concept we are going to apply in the matrix form. So we have addition matrix, a subtraction matrix, the multiplication matrix, the scalar, the determinant, and the inverse matrix. So for you to do this addition subtraction, you have to look at whether these matrices are the same or has the same identity. When we say the same identity, we mean row and column. Row and column should be compatible. So, for example, you will be given this kind of a matrix, and then you will be told to do what? To do either subtraction, multiplication, this one, determinant, or the inverse of that matrix. So how do we call this matrix? Or what is the name of this matrix? Not even the name. Is this matrix convertible? How many rows and how many columns?
It is not convertible.
It is not compatible. How did you how did you come up with that conclusion that it is not compatible?
The first one is a 2 by 1.
So it is maybe, or we can rewrite in this form: 2, 3, 1, 1, 1, 2. Okay, what the number of rows here we have? The number of rows in this case is 1, right?
Yes.
That is 1 by, this one is 1, 2. This one is 1 by 1 by 2, right?
Yes.
That is row. What about the column? The column is 1, 2, 1, 2. So the column here is 2 by 2, right?
Yes.
So you said now this matrix is not compatible.
It will be hard for you to add that matrix.
So it is compatible. Reason is, look at the 2 here.
Okay.
Yes, so this matrix is compatible. You can get the subtraction, you can get multiplication, and that all that. Now, if you come to this inverse and this determinant, you'll be getting the matrix which are not convertible or compatible. That now you have to do that until you get the compatible matrix. When you say determinant is just you are getting the different. You are getting the different between a primary diagonal, and what? Secondary diagonal. Secondary diagonal. So in this case, for example, this matrix. This is the primary diagonal we are talking. So it will be PP, PPD, PPD, and then this is the secondary diagonal. So it will be PPD minus SSD. That one will give you the determinant. That one will give you the determinant. Now, so if this is the matrix, if I say the inverse, I have to raise this one by -1. So if I raise that one by -1, it will be the inverse. So for me now to get the inverse of this matrix, it will be 1. We divide by 1, 2, 3. So that is the inverse matrix. This is the inverse of this matrix. So instead of showing like this, we just raise by power -1. So you will get more concept, or it will be very easy to understand when we use an illustration. So I think now we can jump into some of the illustration. You have past papers?
Is the one you shared?
Yes. So look at the November 2019. There is a small function for November 2019 there. That is quantitative analysis, CPA. Quantitative analysis, CPA, November 2019.